Okay, right. Now what I've done now is I've got a larger graph up on the screen, and the way I got that was right-clicking on this small graph on this side and choosing Analyze, and then this other window pops up, which I hope you can now see. Okay, and what I want to do now is this is for mass A, okay, and I'm going to have it in the X position, and hopefully you can still see that data tool there. Okay, and what I want to do now is choose, this is showing me the X displacement against time, and I have just highlighted a section of that. I want to make sure it's a straight line actually I'm doing, that's the after bit. Right, I want the before the collision. So I'm highlighting a straight line section here. I might just try and include that point there because we don't have many points there. Okay, and I have chosen, under Analyze, I've chosen Curve Fits, and the fit name is Line. Okay, that's giving me a straight line fit. So it's giving me dx by dt, the gradient of that line. That gradient is parameter a. I mean, it's an equation. The equation of the line is x equals a times time plus b, so y equals mx plus c, except this is showing the x displacement against time, and parameter a is the gradient. And you can see the gradient of this is, okay, I'm going to ignore the minus signs because we don't care about the minus signs, is going to be 5.074 times, this e to the minus 1 means times 10 to the minus 1. So my velocity is 0.5074 meters per second before the collision in the x direction, and this is for mass A, the one that we started off with. Okay, and if I want to see what it's doing after the collision, I just have to highlight this section here, and it's put a straight line fit on there, and it's given me a velocity in the x direction after the collision for mass A of 0.1273 because I've got the 10 to the minus 1 factor in there. Okay, hopefully that's clear. Now what I need is what happens to it in the y direction. So to get the y direction, I have to go back to this menu here, click on the axis label and say y position, right click, Analyze. Hopefully you'll see that data tool again. Okay, and it hasn't moved in the y direction at all before the collision, but because it just moved along that straight line. But after the collision, I'm going to choose a straight line section here, and the velocity after the collision in the y direction is right, now we've got 8.488 times 10 to the minus 2, which is 0.08488 meters per second. Okay, that's for mass A. I can do it for mass B. I can just change it on this menu here. Again, right click and Analyze. Okay, and this is giving me the y direction at the moment. So if I choose this, the velocity in the y direction of mass B after the collision is, again, so down here, parameter A, 4.057 times 10 to the minus 2 meters per second. Okay, and if I want to do that in the x direction, I just change it back to x direction, right click, Analyze. Hopefully you'll see that up there. And I choose this straight line section here and look at its gradient. Once you've done this the first time, it does it all automatically, and I can see that my velocity is 0.2771 meters per second. Okay, so what we have now is we have a velocity in the x direction of mass A before the collision. Okay, that's our first velocity vector. We have x and y components of the velocities in the x and y direction for both mass A and mass B after the collision. And what we're going to do is we're going to combine those two component velocities using Pythagoras to find the magnitudes of those velocities after the collision, and we're going to use tan to the minus 1 y over x to find the direction, the angles that they make with the x-axis. Okay, I hope that's clear. I'll switch this off now.